Okay, so I'm from Brazil, as she mentioned. I'll be presenting our team's approach to the placing task this year. I actually joined the lab this year, so much of the task was already in progress and I couldn't contribute much. But I'll try to answer your question, or eventual questions as much as I can. So the general pipeline for our approach is this one. We start from the objects we are interested in, either images or videos. We apply a series of feature structures, generate ranking lists for each of them, and then we use a genetic programming approach to combine those lists, and then from the final ranked list we retrieve the top item, the most relevant item. So an important feature change from the last year's submission is this this graph-based technique in which we change the importance of a certain item based on the density of this item in this graph we build. So this graph is built on based on the distance, the geographical distance between the items, and we use 3 neighbors for the graph, and then the most relevant graph is based on this density analysis. So breaking down the genetic programming approach, we have a series of rank aggregation functions which we use to build our individuals for the genetic programming. We use a series of rankers to build our ranked lists, and then we combine the rank aggregation functions and the various ranked lists into an individual that is capable of combining the ranked lists, and we apply this to estimate the coordinates. During the testing phase, that's just what I meant. So we input the carry, which is the image we're trying to estimate. We compute the ranking, use the discovered rank aggregation function, and then we take the top item from the final ranked list. So some parameters for our genetic programming framework. We use 20 generations, a series of genetic operators, and in bold there, the rank aggregation methods is the RLDA approach I presented earlier. So this is what changed mostly from last year. And the fitness functions we used are FFP1, which is based on the relevance, considering a 1 kilometer range for the items. And the WAS is also based on the geographical distance, but in this case it is explicit in the fitness function. The features we used are these 4 features for textual data. For visual data, we used those features provided by the task organizers, and the features in bold are features we extracted ourselves. For videos, we use the HMP features because we didn't have time to compute all the other features. So the submissions, according to what you presented, we use these configurations. We can see that for the visual features only, the HMP features were used only with RLDA, since we only have a single feature for that. And for the other submissions, except for round 4, we combined all the features, as I said earlier. And the 4th one actually is a comparison between what we had earlier, which was last year. So we submitted the solution from last year so we could compare from the changes in the data set what has improved. Okay, so oops. So those are the results on pictures. So we see that comparing the run 3 and 4, which are the same features but different approaches, we see that our new, including our LDA into the genetic programming framework, has very marginal improvements, and textual features actually are better in some cases. We think that is related to the genetic programming framework when it is presented with ranked lists that are very different in terms of quality. When you have a poor ranked list and a good ranked list, it can degrade the results. So that's what we're seeing here. On videos, you can see that visual features are have really poor results. And we've been also been discussing this visual features being very hard to estimate the geographic coordinates in the technical retreat. So we think that we don't have a solution for this yet. So these are the numerical results for the errors. So the average error and median error for the estimated coordinates and the final coordinate, the ground truth coordinates. And the conclusions are that the framework is good at combining lists, but not good at combining lists which were very different in quality. RLDA improves the quality of the aggregated lists, but marginally. So we feel that our solution is already exhausted in terms of improvements. And including the CNN-based feature extractors, actually improved in comparison from last year, from what we tested. So we think that for future work, we should focus more on deep learning for this problem. Actually, we are inspired into some solution based on planets, which could be useful in terms of the hierarchy that we have from the ground truth, where we can split the globe into many kinds of fine-grained or more coarse regions, and that could be useful in extracting more features. So that's it. I'd like to acknowledge these entities and the task organizers for answering our queries and helping us.
Yep, thank you very much.